Hello, everybody. We are super excited to be here and talk to you about how Docker is thinking about agents. But more importantly, we're excited to help you, all the developers in the room, be able to build, not just buy, but build and run your own agents using the tools and techniques that you already know and love. Now, you might be asking, maybe you're not, but you probably are, why Docker? Why am I listening to Docker talk about agents, besides that everybody talks about agents? You're the container people. You're a container platform. You're not an LLM company. Well, if you allow me a small digression, it'll make sense. If you go back in time to when Docker was created about 10 years ago, thank you, Solomon Hykes, Docker made microservices and cloud-native architectures possible. And it's not an overstatement to say that, because at the time, it was only the most advanced and really motivated developers that wanted to put in the work necessary to make their apps run, at least properly, in the cloud. And it wasn't just because distributed systems were new and novel and required new techniques, they did, but actually it was because the environments between your laptop and prod were just so radically different. It was just hard. And Docker changed that. Docker made it easy and accessible for developers of all kinds and all walks to get their things running locally and in production. And when we look at agents, it's almost the same landscape. There's so much excitement. There's so much innovation. There's so much new technology. But there's a lot of complexity. And it's not easy to go make something that is open, portable, and agentic. But Docker's changing that, and by the end of the talk, I think you'll be excited to go build and run your own agents with Docker. Now, Docker did, of course, make containers, and we made containers mainstream, but it was actually some key principles that made this transformation possible. These are the originals from 10 years ago, by the way. Build once and run anywhere. Give developers infrastructure-agnostic portability and a smooth path from development to production. Be open source and community first, not just Docker itself, which was and is open source, but actually enabling the entire open source ecosystem to become cloud native and ultimately container native. And lastly, most importantly, empower you, developers, with a great developer experience and make things simple and accessible, and frankly, just fun and satisfying to get things running. And I have one more thing I want to talk about before we talk about agents, which is AI, which there's so much energy going into this, like we all know, we're bombarded by it every day. But there's this question that everybody asks, which is AI going to take over? And am I going to have a job? Are people going to have jobs? Like, what's going to happen? And there's a lot of rhetoric out there that says, yeah, we're screwed. AI is going to take over, and there's not going to be jobs anymore. But actually, we have a pretty contrarian opinion to that. And rather than tell you the direct answer, I'll tell you a story. It is a bit of an old story. I was just introduced. I have 25 years of experience. It goes back to the 1960s when people still used banks on a daily basis for cash. But in 1969, the first ATM machine was installed. At the time, bankers and bank tellers panicked because obviously technology was going to eat their job. And then everybody panicked because technology was clearly going to eat their job next. But that's not actually what happened. What actually happened was banks ended up hiring more tellers and more bankers because ATMs took away transactional work and repetitive work. And the bank tellers shifted to doing more advisory work and brought in a lot more revenue. And banks used more revenue to open up more branches and offer more services. And the thing is, I think this is what's actually going to happen with AI. Yes, it's going to transform our jobs probably radically, probably more radically than we can even imagine. But at the end of the day, it's going to take away a lot of the tedious work for us. And it's going to let us go build faster and go further than we've gone before. And let you solve only the problems that you can solve, the hard ones. OK, so that's AI. Let's finally get into agents. Before we talk about agents, I do have one more spicy thing to say, which is, I don't know about you, but every time I talk to somebody about agents, the first question that gets asked is, what's an agent? Because everybody says that word and like it means whatever the hell you want. So it's important to start with the definition. Here's ours. And obviously, an agent is an autonomous system, but I think you have an agent when you've had three properties that are true. First, you've actually given over your decision-making and your control loop to the LLM, or the model, meaning you don't just call it anymore, it calls you, and it drives things autonomously itself. This is subtle and nuanced, but it's like one of the key principles you have to understand. Secondly, you've connected it to your data and your environment. Like anybody can go to ChatGPT and ask it what it knows about. It knows a lot. But only an agent that you've built and connected to your systems knows about you. And lastly, probably most importantly, you're not thinking in terms of tasks and just completing basic things anymore. You're thinking in terms of goals. It's never been possible before to program the way that humans think in terms of objectives and outcomes. And ultimately, that's what building agents is all about. And that's what's so exciting, and that's what's so powerful. OK, so that's a definition, perhaps an abstract definition. You can make it concrete with a couple of examples. So first, we're all developers in the room. Imagine a release notes agent. I don't like doing these things. I don't know any developer that does, and frankly, most of us aren't good at it. But so, imagine your team has submitted, I don't know, whatever, 125 or 200 pull requests, and of course, nobody wrote notes. This never happens. Well, you can have an agent that actually takes care of this for you. You could go build this today. It can watch your PRs. It can group them. It can understand what changed. It can go write human-readable notes. It can update the changelog. It can update the docs. It can prepare a version tag. This is all super tedious stuff that nobody really likes doing, but everybody appreciates when it's done. Secondly, imagine running an e-commerce store, so a business goal. Like perhaps it's a sock store. We developers, we do love our conference socks. And business is booming, and you can't keep supply in stock, and everybody wants to come get their socks sold in your store. It's a lot of work to onboard vendors. You have to go vet them. You have to look up all their information. You have to figure out if they're a match, etc. You can write an agent easily that takes their SKU information, their photos, their pricing, their supply chain, their materials, and go match it against your internal database and see if your buyers buy what they make. Like maybe you only buy organic cotton and they make spandex, I don't know. And you can go look at things like Reddit and look for customer sentiment. Maybe they have praise, maybe they have complaints. And ultimately, an agent you write can make the decision for you, should I onboard this vendor? And if so, create an entry in your database and offer their SKU for sale. If no, suggest changes or reject it outright. At the end of the day, agents you write are able to act on your behalf and apply judgment and context and ultimately solve your goals. Okay, so that's a definition, that's a couple examples. I want to talk briefly about where agents are going, not in the next 5 years, but in the next 5 months to 5 weeks, like basically what's happening now. And there are two things to really land. First, agents are going to be multi-LLM. So you're going to be doing this. It's all about context engineering. You have to give the right prompt and the right data and the right tools and the right information to the right LLM at the right time. Sometimes only a big model like Gemini or Claude will work because it does advanced reasoning. Sometimes you need to have your own fine-tuned model. Maybe it's multimodal and something trained off of Lava. Sometimes you want just an off-the-shelf open or local model for cost or latency or sovereignty and privacy constraints. On that note, Docker, we are fervent believers that actually the world is going to embrace local and open models much more rapidly than they have been, because it just makes sense. It's the same way they embraced open source. But whether you believe that or not, you're going to be mixing and matching models. That is absolutely what's going to happen. Secondly, if agents are going to become multi-LLM, we'll actually see agents become compound, and we'll see multiple agents. And there's probably a pun here, but we'll see swarms of themselves talk to each other. At the end of the day, they'll be able to solve increasingly complex and compound goals, and they'll have to discover each other and call from each other and learn from each other. Ultimately, they're going to surprise us. So that's cool. That's where it's going. But I told you at the very beginning, it's not easy to build something that's open and agentic and portable. So what do we have to solve? Well, if agents are going to be multi-LLM, then you need to be able to very quickly and portably bring different models into your application and try them out, figure out which ones iterate with them, figure out which ones work for your context and your goals. You'll be able to find tools and connect it to your data. This is where MCP comes in. It's like service discovery for agents. And lastly, you need a hub, dare I say, a place where you can find and publish all of models, tools, and agents, not just to distribute the code, but actually to give confidence and trust in what you're using and what you're sharing. And the thing is, above and beyond all this, you have to be able to put all these things together and describe them declaratively, easily, and simply, and share them, and then run them locally and in testing and production. This is what Docker is, and this is what Docker does. And these challenges are, new for agents, but they're fundamentally the same challenges that we solved once upon a time for cloud native. And required new extensions and new features, but we're solving them with the same principles of build once and run anywhere. Be open source and community first, and empower devs. We're solving them for agents. To show you how, rather than me keep talking about this, I'd actually love to welcome Tushar Jain to the stage to walk us through the tools and workflows that you can use today to go build your own agents. So Tushar, take it away.
Thanks, Mark. Thanks, Mark. All right. So you just heard Mark talk about how the challenges of building, packaging, and running agents today remind us a lot of the problems Docker solved to make the move to services easy. Why can't we just pull and run models? Why can't we just pull and run tools? Why can't I just pull and run an agent? That power, that simplicity of pull, run, up, that was key to making cloud-native computing take off. And now it's time to do the same for agents. And we're going to do this the Docker way. We're going to build in the open, integrate with the ecosystem, align with standards, and make this simple for developers. So let's talk about how we're going to do this. We'll start with models. In addition to large frontier models, open and local models are going to be a key part of every agentic stack. Whether this will be for privacy reasons, cost, governance, or with things like SLM for performance reasons, Developers are going to need to be able to choose the right models for the right task and mix and match this in their agentic stack. And we're making this easy. With Docker Model Runner, running a model is as simple as running a container. Simpler, in fact. You can stay in your existing workflow, no new tool chain, no complicated setup. It's as easy as Docker Model Run. And we've paired this with a large and growing catalog of models in Docker Hub. All the popular models you expect are there. Quen, Gemma, Llama, etc., and a lot more. We've also built all of this to be OCI compatible, meaning models are packaged as OCI artifacts, just like containers, so you can plug this into existing infrastructure with zero friction. If you're already using an OCI registry, you don't need to change anything. Using a tooling, you can also build and package your own models as OCI artifacts, put them into your registry, and just point the Docker Model Runner to it. Simple and easy. We've also open sourced the Docker Model Runner. Contributions welcome, PRs welcome. A question I get asked often when I talk about using open source models is, hey, what if these models don't fit on my local laptop? How can I use them? Hold on to that thought. More on that in just a few minutes. All right, next, let's talk about tools. Tools are critical. They're what allow an agent to actually interact with your data, your systems, your APIs. MCP has clearly become the standard here. However, a question we get asked often is, how do I know what MCP server to use for the system I'm trying to work with? This is where Docker's MCP catalog comes in. We've built a large and growing catalog of MCP servers in Docker Hub, 100+ and counting. This is a registry of trusted, verified, secure, containerized MCP servers. You can easily use these tools by themselves, or plug them into your agent and access the full catalog using our tooling. With Docker Desktop, you can easily connect to the entire catalog and easily configure tools like Cursor or Claude and simply enable disable any server you want. You can do this through the UI or through the CLI. No more mucking with config files manually and reloading things, etc. OK, but now what if you want to take these tools and plug them into your agent, not connect to tools like Claude and Cursor, but writing your own agent? This is where I'm really excited to talk to you about MCP Gateway. MCP Gateway is a proxy MCP server. It presents itself as a single MCP server, but connects to the entire catalog of tools on the back end, and manages execution, runs them securely as containers, and gives you a central way to expose any tool you want, any server you want. And the proxy architecture is really powerful. You can now select any server to expose, scope down the tools to expose from there, add observability, logging, security configuration, and we have a very flexible interceptive framework. So you can do things like plug in any script you want, any tooling you want, your own security rules, or modify responses after an MCP server comes back. In addition to observability and security, we've also found this really powerful just for improving agent performance. Two quick examples. A lot of MCP servers out there today expose a ton of tools, but we found that agents can start to perform worse if you give them a lot of servers and a lot of tools. With the gateway, you can scope down tool access and only expose the tools that you know you're going to be using. Second, a lot of servers are highly verbose. And we found that by scoping down the response or filtering it down to just what you need, you actually improve performance here. And now, instead of mucking with the MCP server or changing your agent code, you can easily write an interceptor, even something as simple as just exec out to a JQ script if you want, and modify the response and give it back. It's highly configurable, and it's a really powerful architecture. We actually think that this is a really powerful tool, and we think this is the right architecture for how to deal with a large and growing catalog of MCP servers. This way, you can connect your entire catalog and dynamically control what is exposed to the agent. And I'm really excited to announce that just yesterday, we open sourced this. Please go use it. Please contribute to it. We would love your PRs. Oops. All right. So we've just talked about, I teased that a bit, pretend you didn't see me click the next slide. We've just talked about some really powerful building blocks. Docker Model Runner makes it really easy to build and run models. The MCP toolkit, the MCP gateway, makes it really easy to work with a large catalog of MCP servers. But when you're writing your agent, you actually want to bring this stuff together. And architecturally, what I really want is I want to write my agent, run it as a container, have the gateway running as a container, and have the model runner running, and have these easily wired up. So I kind of want multi-containers all operating as a single unit. This sounds really familiar. Now the next slide. Compose is probably the most loved Docker technology out there. It's used by millions of developers actively, and anytime I talk to anyone about it, all I hear is how much they love it and how simple it is for them. So I'm really, really excited to talk to you about how we're extending Compose to have it support agents natively. Models, let's start with model again. Models are now a top-level native keyword in Compose. You can easily declare the models you want to use. This connects to an OCI registry, hub by default, and pulls down the models, runs them via Docker Model Runner. With the MCP Gateway, you can put in the tools you want to use and connect the MCP servers and tools you want to use with all of the configurability we just talked about of the MCP Gateway. And then your agent wires this all together. So now, this is just Compose standard normal form. In a single file, you can define your entire agentic stack, models, tools, wire them all up together, and bring your entire agent up just by doing Docker Compose up. This makes it really simple now to get going. And, thank you. And we're not stopping there. We're extending this and meeting developers where they are by integrating into all the agent SDKs everyone's already using. These are just a few of the popular ones we've already integrated with, and we're working with the community to integrate with all of them. Again, this is open source. Please come contribute. We will love participation here. The goal of this, though, is that this makes us we are language agnostic and code agnostic. You can define your agent using in any language, any framework you want, but still use Compose to wire it all up, package it all up, access the tools, access the models, and bring this all up easily just by doing Docker Compose up. The goal is simple. You work on an agent, we want to make the rest easy. All right, enough talking. Let's go make this real. So please join me in welcoming Jim, who's going to play with the demo gods and show us how this all come together with a live demo.
Oh, wow. This is awesome. Mark earlier talked about building an agent to manage an online sock store. So that's what we're going to do. The starting point for this is actually an app that many of you may have already seen. We built a microservices demo about 10 years ago, funnily enough, called the Sock Store. And we're not changing this at all for this demo. We're just going to use the Sock Store as is. It's got a catalog service for us to add new entries into, and it's got a database for customer reviews. So it's basically got context that we can already give to our agents. What's new here is we're going to build this scenario where I don't want to be entering new socks into my sock store. I don't want to be going online and figuring out whether a company is real or doing any sentiment analysis. I just want to build an agent to do this for me. So this agent that we're building here is going to have like 3 different cooperating agents. So the first one is a Reddit research agent, goes out, takes a look at the new sock that we want to put in, sees if there's any online reviews that look good. We've got a customer feedback agent, which is going to use private data from our customer review database to see if this product aligns with the sort of thing that we want to have in our sock store. And finally, we've got a sock store catalog agent to sort of make a decision and put a new entry into the catalog. So these agents are a bunch of prompts. What did we talk about earlier that makes up an agent? Well, we need models too. And 2 of these agents are just going to be using GPT-4. Why do we choose GPT-4? It's a good starting point. It's a good model. Not a huge reason here. It does tool calling. It's all just environment variables. When you try out this demo, you can switch to other models as well. But here's where it gets interesting. The Qwen 3 model. This is a local model that we're giving to our customer feedback agent because it's going to be looking at private data from our database. So why are we using Qwen 3? Because we don't want any of this data going to cloud models. We want to use a local model here. Again, Mark talked earlier about hybrid LLMs. This is an example of that. We're using GPT-4 and QN3. And finally, the other thing we want to compose in here is an MCP gateway. So all three of these agents need tools. And once we've pulled this in, our agents will entirely go through this MCP gateway in order to get stuff done. That includes making entries in the catalog service, and we're using the MongoDB. All right, so let's get a terminal and get started. So the first thing I'm going to do is take a look at the existing sock store, Compose application. It's just a bunch of services. We got a front end, we got a catalog DB. So let's bring up our handy coding assistant, and I'm going to put in Claude Code. I'm going to put in a little snippet that I already created. So this is a little two-sentence start here. What do I want to do? I want to start with an existing Compose file, and I want to add the QN3 model to this service. I also want to add the MCP gateway with 4 MCPs. I want to use Brave, I want to use Resend, I want to use curl, and I want to use MongoDB. So a very, very simple prompt. And you could more or less do this with any coding assistant. You just need access to the docs and a sort of an understanding of what you want to build here. So it's breaking it down into a couple of different steps here. And the first thing it's going to do is add a model. So this is a top-level element in Compose now. It's going to use the 14 billion QN3 model. Good. Next thing it's going to need to do is sometimes it does the steps in different ways. I often wish it would kind of go through this demo the same way each time. You're getting excited about things when you're like, why is this AI not doing it exactly the way I want it to do it? But here we go. The ADK service now has a QN3 model, and we've injected 2 environment variables so you can control how to look up this model within your service. Next, we're going to add the MCP gateway, I think. And yep, that's the next step to happen here. So we got the agent is almost giving us a little online tutorial for how to set this up. So the MCP gateway that it adds has Brave, Resend, curl, and MongoDB. And I think the final step here is going to be adding our secrets. And that should be all we need to compose up this agent. Yep, that's good. And so let me Control-C out of that. And now we're ready to just type docker compose up. And this is bringing up everything that we've just talked about. So it's bringing up the entire sock store. It's bringing up our model. It's bringing up our MCP gateway. And let me make this a little bigger. And by composing up here, this is the sock store demo. It's running on port 9090. We've got a bunch of socks here, and we've got one more endpoint that we've added to this demo on 3000. This is our portal. This is a little Streamlit app that we built to talk to the Agent Developer Kit demo here, to talk to our agent. So let's create a session, and let's bring in a prompt. I am a sock vendor named Neek. Perhaps you've heard of us. We provide colorful compression socks that are elegant and affordable. So let me fire that off. All of the data that we've been building here is just generated itself by LLM. I hope there's no one from the company Neek here in the audience. What was the first agent that we built here? It's a Reddit research agent. So we're now going through and we're doing some queries against Reddit to try to figure out whether there are good or bad reviews for the compression socks that we're thinking about adding here. And let me also bring up a GPU monitor, because in the background, and I'm going to switch over to the actual Compose stack, the Compose console here, we're using the 14 billion parameter QN model here. And once it starts working, it's a pretty big model for my particular for my machine here. I don't have a really great modern laptop, and so as you can kind of see here, the GPU is pegged. It's not running particularly fast. We're in the middle of a demo here. This is totally not my fault. If anything, it's probably Tushar's fault for not getting me a better laptop. A little bit of corporate hardware hacking. So let me Control-C this, and I'm going to do a little trick here. So I'll bring up Docker Desktop, and we have a tool called Docker Offload Start. And I ran this a few minutes ago before getting on the stage. But what that does is it allows me to offload the work that I'm doing here to another GPU, a better GPU. And so now, if I look at going Docker context, use, and go to my offload context here, I'm going to be able to switch to the cloud. And so now I have good GPUs. And I like these GPUs well enough that I'm actually going to look at my compose file here. And I know I've got an NVIDIA GPU attached to this context now. So forget about a 14 billion parameter model. I'm going to use a 30 billion parameter model. I'm going to bump up my context size. I've got some space here. I've got like some good hardware. So let's go Docker compose. Exactly the same compose file I used before. So this one is identical to what I ran locally. But now I'm going to also bump up the size of the model and the context size. Let's bring that one up. Again, this is all the same services. This is a slightly bigger model. It's the same MCP gateway. And it is. This could be a situation where there's a demo god problem. So I did actually come prepared for that. Let me stop one time and compose up again. Yes, this is a demo god problem. So I do have a video here that I'm going to switch to. It's on my desktop, and here is the okay. Let me make this a little bit bigger. So I made this video for about like 10 seconds before we started here, but so. We're going to switch over to the cloud. We're going to switch over to the cloud context here. I'm going to go through what I just said to you. We're switching over to a 30 billion parameter model and context, a different context size. Now, this is the part that will work this time because this is just a recording. So the model comes up again, and the sock store comes up, the MCP gateway comes up, and I'm going to switch over to the portal again, create a new session. I'm going to put exactly the same prompt in, and this time, as we go through this, you're going to see that the GPU picks up when we get through the Reddit research agents. The catalog agent is going to be able to come up more quickly and get to our customer, our ability to actually put a new sock into the store. This is some of the. If you want to try out this demo, of course, take a look at it. If you're opening up these tabs, you're going to see a bunch of the research that's been done. See, this is the 30 billion parameter model that's running. And let me actually just, oh, there we go. There's the customer feedback agent coming in. It's doing some MongoDB queries. And let me bump this up a little bit faster here. And there we see some socks. So that is our ability to offload to new GPUs. So with that, I will hand back to Tushar.
Thanks, Jim. That was brave, playing the demo gods, not just doing a live demo, working with LLMs live. So not too surprised something didn't work exactly as expected there. It's one of those things, you run it 10 times right before the stage, works well, come here, and who knows what's going on. OK, that said, I don't know about you all. I found that really exciting. Every time Jim walks through that, I get really excited. We just saw how to define your agents simply in Compose, get it all stood up, work within existing SDK, and get it spun up. To help make this easy for people, we've open sourced a repo with lots of examples using Compose and a number of agent SDKs there. Please go here, please check it out, and we think it's a great way to help people get started. All right. That said, Jim did steal my thunder a little bit. He showed you Docker Offload. So I am really, really excited to announce a new service that we're launching today. It just went live right before this call, Docker Offload. This is a brand new service that natively integrates with Docker Desktop and Docker CLI tooling and gives you a remote engine with a GPU. You get the same local field that you saw Jim show, but now you can accelerate your inner loop by using a GPU. This makes it really easy to work with models. What if a model doesn't fit in your laptop? That's easy. Just do Docker Offload start and start running a 30 billion parameter model or anything else that's there. We've priced this aggressively with a general free tier. Also, this is multi-region. In fact, when Jim was doing that, because we're here in Berlin, he was routed to a data center in Europe. That means he could work with the local model with his private data and stay within the geo boundaries here and not get routed off continent. This is live now in beta. We'll have sign-up instructions in just a bit. OK, so we talked about how you can define your model, your agent easily in Compose, how you can get it spun up, work with the existing SDKs, use it locally, accelerate your local loop with Docker Offload. But what about production? As we're thinking about this, we realized that Compose is actually it's the right form factor for us. But now what would be really nice to get this to production is actually serverless would be great. What if I could just take my Compose stack and run it in a serverless manner in production? That would make this really easy. And I want to do it by taking the exact same Compose file and just go run it. Make this super easy for ourselves. That would be great. Luckily, others agreed with us. I'm really excited to also announce that we're partnering with GCP and Azure to bring serverless Compose to the cloud. You can now take the exact same Compose file you saw us do, define your agents, and run it in a serverless manner with GCP and Azure Container Apps. With something, as an example of that, with something like GCP, this becomes as simple now as doing Docker Compose up and clicker will work. There you go. G-Cloud run compose up. That's it. You take the same file and do it. So let's make this real. Please welcome Yunong from the GCP Cloud Run team to walk us through this.
Thanks, Tushar. Hey, everybody. How are y'all doing? All right. I am really excited to be here. Most of you might know Google Cloud and Cloud Run is our serverless compute offering. And where we really position it for is for all of you, developers, right? So it is the easiest, most ergonomic, most cost-effective way for you to bring your applications to the cloud. Now, we're focused on things like reliability, cost-effectiveness, performance. But we know, and you all know, that developer experience and developer ergonomics is super important. And so that's why we've spent a lot of our time making sure that Cloud Run is the best developer experience for all of you. And what we want to do is meet you where you are, which is making sure that Compose just works natively on Cloud Run. right? Have you used the tools you already use to deploy on the Cloud Run? So as Tushar said, you can just run gcloud run compose up with a compose YAML that you have with Docker natively, and that will deploy the whole suite of applications as defining your compose file on the Google Cloud, on the Cloud Run specifically. Now, let's make this real, as we talked about, and let's get right into a demo. So if we can move to the demo, please. I will actually show you all how easy this is. We'll just give it a minute for the AV to kick in. Is this working? OK, great. Friendly neighborhood console. Give me 1 second. I am not connected to Wi-Fi, so that's always a good thing. Give us 1 second here. This is how you know it's a real demo. All right, so now we're connected. Okay, so now we should be connected. Just refresh the page here. All right. Let's try this again. OK, cool. We now actually have internet connectivity. In the event that the AI overlords overtake us, we just drop our internet connections and we shall be fine, right? So. All right. OK, cool. So this is my terminal. Is this? Yep, there we go. If all of you could turn off Wi-Fi on your phones, this would really help a lot. Stop downloading movies. All right, we got some latency here. OK, cool. So here is my demo compose file. And you'll see here, this is exactly the same demo file, compose file that Jim showed earlier, right? So we've got lots of different services as part of the Docker compose file. It is exactly the same architecture. One of the things I've changed is we're using our homemade Gemma 3.3n model. And again, we think this is the smallest but fastest world-beating open source model that's available out there for you. So encourage you all to take a look. But otherwise, this is exactly the same Docker file, compose file that we had earlier. So OK, so we still have internet connectivity issues. My terminal is not responsive. Oh, there we go. Now we're back. OK, so as we showed earlier, it's as simple as running gcloud run compose up. And what this is going to do now is take that compose file, map it to all of Cloud Run and GCP's APIs, and deploy a set of 3 services and projects, each with individual containers and services underneath them. And we'll show you that in a second. While this is deploying, actually, I just want to talk through that. Cloud Run, not only does it support compose today, but there's multiple ways to deploy, right? So that you can use the APIs, you can use the CLI that we're using today, you can use Terraform, you can use the UI as we talked about. But we think that having this compatibility with gcloud with Docker Compose makes it super simple for all of you, as it's a tool that you already are all familiar with. So we'll just give this a second. This should actually run relatively quickly. But given sort of the internet connectivity issues, I suspect this might take a little bit longer for the console to come back to us. OK. Let's give it a second. There's something wrong with the internet here, so it's unfortunate. OK. Let's try this one more time. We're going to disconnect and connect back on. Yeah, there's some internet connectivity issues. So if there's LAN, that would be fantastic. Look at that. All right. Always make sure you have a hard connection. OK. So I can turn this off, right? There we go. Okay, cool. LAN connection. Woo! All right, we'll do this one more time. But in the time that we were talking about this, we actually did deploy the application, as you'll see. Oh my God, this is great. Okay, so what I'm going to do here is I'm going to come to the Google Cloud Console, and this is where you see the 3 applications that we just deployed. I'm going to speak a little bit more quickly because we're a little behind schedule due to internet connective issues. So you'll see here, this is the demo part of the application. And if I click on revisions here, you will see that we actually deployed 4 individual containers as part of the demo container, demo project. We got our MongoDB, our MCP gateway, our ADK container, and the UI container. We've also got a AI model service, and this is what's hosting our LLM, which is our Gemma model. And again, you can see here, we've got a NVIDIA GPU that's attached, also as part of Cloud Run. And then lastly, there is the catalog service. This is part of the Docker catalog service. The nice thing is, if I click through to the demo here, and I click on this URL, this takes me to the same sock shop vendor, so that's 3 times fast, that Jim showed. So we can create a new session and say, I would like to sell Google Tube Socks for $13.37, right? So this is not going to go do that. While this is working, the other thing that I'd like to show, the advantage of being able to run on the cloud is, while this is an app that I just deployed today, this can scale, right? We have customers scaling to 1,000 QPS to 1 million QPS in specific regions of the world. So I have a load tester here, right? And what this is going to do, it's going to start 1,000 concurrent jobs and go query the AI model. So this really demonstrates the power of Cloud Run and running in the cloud. So we can see now, right, responses coming back from the agent. And then here, what we're seeing is Google doesn't produce stocks, shockingly, right? But we can find them somewhere else. So that was the demo. And you can see here, of course, as well, as we're getting a whole bunch of responses back from a load generator. So let us please switch back to the deck. Can we switch back to the deck, please? I thought about coming on stage and saying developers, 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 developers all over, but didn't think it was appropriate. There we go. Back to the deck. Okay, cool. We're going to go through blazing speed. So what are the key features that we've launched for Docker Compose support on Cloud Run? One, as you saw, you can deploy multiple container applications, right? Your AI apps are very complex. Cloud Run supports that. Parallel cloud-based builds. So you just saw the deployment speed. That was super fast. It's using parallel builds in the cloud. This really shortens your inner loop and makes the developer experience really great. Volume support. So full access for all your stateful workloads, whether it's conversational history or request queues, et cetera, that's all supported. And lastly, integrated secrets. So that's all part of the Google Cloud and Cloud Run experience. You can call to any other Google Cloud service, like the Gemini API, like Cloud Storage, without having to manage or see any of your security credentials. And so why choose Cloud Run? Well, first of all, I think for all of you, it is absolutely the easiest way for you to get your applications onto the cloud. Right? We have the top CSAT and usability scores. You can run any AI agent and applications in any language on Cloud Run. It's completely free, it's agnostic to whatever it is you want to use. It's the fastest way for you to get your application on the cloud. Second, it's really cheap, right? When we deploy that app, if I don't send a single request to it, you don't pay a single cent. So it's pay per use, it's automatic, it's on demand, and it rapidly scales. Right? There's no infrastructure to manage. So when you scale up to 10,000 requests per second, 1 million requests per second, it'll still just be as reliable as when you're at 1 RPS, because Google is your SRE. All right, so we also showed GPUs. We're very happy to announce that this year we came out with Cloud Run with GPU support. So it's exactly the same thing that we showed for CPU-based applications, but now with the power of GPUs, it's on demand, it scales to 0, it starts fast, and you pay by the second. And this is really great for you to be able to build your own models, right? Use your own models, use open source models, or use your fine-tuned models. And here, what I really want to double down on is our really fast speed to start, right? You can start a GPU with drivers installed in 5 seconds. I challenge you to find a place you can do this more quickly. So again, for all of you developers out there, you can use Cloud Run as your development machine. But this also means that when you need to auto-scale up your applications, it responds really quickly. And so this is really great for things like real-time LLM inference, on-demand image generation, and media processing. So what did we talk about today? We talked about the fact that we are partnering with Docker to support the Docker Compose spec. Sign up for the Compose preview. That's the QR code on the left. We're really excited about this partnership. At the same time, if you want to learn more about Cloud Run, it's the QR code on the right. With that, I will hand it back to Mark and Tushar. Thank you.
Thanks, Yinong. That was super exciting. All right, we're going to turn and burn to make up some time here. This is not just an ad. I mean this in all honesty. You do want to stay till the end. We've got, for everyone in the room, we've got a special surprise at the end here. You'll want the free stuff. OK, I don't know if this landed, but you just saw we defined an agent easily in Compose. We ran the same Compose file across 3 different environments really easily. Locally, offload, the remote GPU with the local experience, and then in production using Cloud Run. This is truly build once, runs anywhere.
That's right. Thanks, Tushar. By the way, we did not plan this little outfit. To let you know, we didn't talk. There's one thing we didn't talk about today, which is, we talked about how you can build agents, but we didn't talk about how Docker itself is becoming agentic and helping you with the overall SDLC. The overall SDLC, software development lifecycle, used to be a collection of tools, and Docker would be the first tool to the right of the IDE, your coding tool. But obviously, everybody's using Cursor and Claude Code and Windsurf by now, and so we're really excited that in the very, 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 very near future, we'll be releasing a new version of Docker that itself is fully agentic and the first agent to the right of the coding agent. And rather than tell you all the list of features, which we don't have time for anyway, then Tushar, why don't you walk us through the demo?
All right, cool. So you saw us vibe code the SOC Store app. That was great. But now, look, we're serious developers. We care about security. And so I want to look at, are there vulnerabilities here, find them, fix them, resolve them. But also, I don't really want to do all this work myself. So I've heard of Docker Agent. Let's see if it can help us. I think we have a video, if we could play that.
This time the demo
there you go. All right.
Fail us.
So I've started Docker Agent. I'm going to run in YOLO mode, because that's our role.
What mode?
YOLO mode. Just don't, you say yes for every tool call. That's fine. Just trust it. All right, so I've asked Docker to build the image, find it, audit it. It's built up a plan. It's going to build the image, audit it, remediate. All right, let's see what it does. All right, 144 vulnerabilities. That's quite a bit. Some high, some medium. It's using Docker hardened images. That's a new product from Docker for secure hardened images. Encourage you to check it out. It's going to update the Docker file. Great. Do non-root users also. That's good. That's advanced. All right. What I see it doing here is it's actually using multi-stage builds. That is great. So those are not complex, the right way to do it, but it's great that I don't have to go do that myself. It's moved to the right base images, made this a multi-stage build. All right. It's doing a whole bunch of stuff. But this is a video because we sped up the agent a little bit. Normally, this would run. I'd go finish a cup of coffee, come back, it'd be done. We just sped it up a little bit as it's calling all the various tools here. All right, so it's built my agent. It's searching for CVEs. Whoa, look at that. I've gone from 144 vulnerabilities to 0. It also reduced the image size by 90%, from 399 to 39. This is great. All right, now comes the Git storm, where it's going to create a pull request for me. And hopefully produces a good pull request that I'm also OK going through a code review process and making through our team. Let's see what that looks like. And it'll be coming up soon. What's been really good about this, at least so far, is I've just had to sit here and watch it. OK, updated the base image, reduced vulnerabilities, reduced image size. That's a well-written PR. This is great.
Better release notes than you and I write.
Better release notes than we write, clearly. And look, it modified the Docker file, got me a multi-stage build. That was really exciting. I didn't have to do any work. I got to offload stuff that is important but also tedious for me and to take advantage of that. All right. We've seen a lot here today. Mark, do you want to just recap this for us?
I can. OK. So remember, we talked about a whole bunch of stuff. We talked about how Docker itself has become an agent. You just saw that. But importantly, you saw how Docker, which you probably thought of us as the container platform, is an AI platform and an agent platform. And we showed you how Compose is super easy. And you can define a multi-LLM, multi-agent architecture easily, get it up and running. You can get GPUs from the cloud to offload from your box. So if you don't have the resource capacity, which a lot of us do not, it's there and seamless and instant. And we showed you don't have to change anything, not one line of the Docker Compose file to get yourself from the laptop to prod. So this is actually super exciting and super powerful. And we're really excited to see what you guys are going to go build with it. And that,
yeah. So we should announce Docker Offload. Here is a QR code. Please, you can go sign up and watch it online. This is open in beta. We'll be enabling developers as quickly as we can. But for everyone here in this room, I think Mark has a special surprise for you. Thank you for waiting.
I arranged this, so thank you for waiting for lunch. So for you all today, we're giving away 50 free hours of Docker Offload compute time. to the first 1,000 developers of you that go sign up. To get there, you got to go to the booth. And last thing, there will be a free pair of socks that are special edition, a limited edition for just this conference. So with that, we hope you really get excited to go build agents. It's easy, it's fast, and we can't wait to see what you do. So thanks, everybody.
Thank you all.